Alrighty, so that seems to work. Hopefully my mic is also working, otherwise it will be a sad day for our friends on YouTube. So how do we want to do this? Igor, do you want to talk about this? Alright, that makes sense.
Good news, Emo. We can hear you.
Yes. Hopefully.
I was talking and my mic was muted, so I will repeat what I just said. My initial thought was I didn't like the approach, but after looking at the C++ usages and realizing that it's doing byte index, not bit indexing, I think it makes more sense to use element index here, and it will probably better match the common use case. And if people do want to do other indexing, they can convert to the appropriate type.
Yeah, I don't have strong opinions. I mean, that seems reasonable too. So anybody else on the call having an opinion on this? I mean, in general, we try to be more .NET than we try to be C++, right? So I don't know whether that helps the decision or not, but...
Right, but I think that the C++ motivation that Tanner was citing was usage, right? This is how it's used, and this is why it makes sense. If I were to paraphrase.
Right.
What's the issue number where we have the proposal for fused multiply add by selected scalar? Because I don't see it in this issue.
You're asking hard questions.
Well, because what I'm trying to do is I'm trying to see what the proposed API was, because it's not listed in this particular issue, or what the approved API was. Because there's the comment with Igor's proposal, but I'm having trouble mapping that to what the approved API was.
What was the name of the API? Fused multiply add?
Fused multiply add by selected scalar.
So basically I can't find the issue number right now. GitHub's not searching. But basically the thing is we approved the first overload, and Igor's asking about if we should also add the second overload, because that's what C++ does. So the first overload is all types are the same, and the second overload has the third type as a vector 128.
So maybe I'm just better visualizing this. So what is the exact API?
The second, you're going to need to scroll down on your screen a little bit, Emo.
Oh, I see. Okay.
I just sent a link to the proposed API.
Multiple screens. Let me find it. Yeah, sorry, which one was the overloads for? Wasn't it the biselector one?
Wasn't it the biselector one?
Yeah, the one just in the middle of your screen there. Oh, you just scrolled past it.
At the top? Oh, yeah.
Right there. Oh no, that's multiply extended.
Yeah, that might have been the second one because this was the thing to... There we go, that's the one, right? How about the fused one, right?
Yeah, I think it was the fused version.
I don't think we have that in here. Use multiply and by selected scalar. We can't find this anywhere on GitHub?
I guess it's fine. We can just discuss multiply by selected scalar because they have similar API with fused versions.
I think I found it. Oh yeah, it's the same. Okay. Open this comment, right? So here's the things that you're proposing, right? Is that fair?
So yeah, in C++, there's these multiple overloads for fuse, multiply, add by selected scalar analogies. So basically, we have overloads that have same vector size for left, right, and addend operands. In C++, right size and addend and left sizes are independent. So they have basically 4 different overloads instead of 2. And the reason why, as Tamar suggested, it's because they don't have easy way to go between vector 128 and vector 64. In our case, we can downcast from vector 128. So instead of exploding all these overloads, we can just have fuse, multiply, add by selected scalar, where right is always vector 128. And in case if we got 64, we can upcast it to vector 128.
Well, it's not quite that simple. So with most of the instructions, the size of all operands are the same. But in the case of FMLA, there's both a Q bit and an H bit. The Q bit controls the size of the result, the addend, and the left, but the H bit controls the size of right. So you can actually have vector 64 left and vector 128 right.
I didn't know that.
Yeah, and that particular pattern will repeat itself quite often for a lot of the by element instructions.
So I guess we would need all these overloads.
Yeah, so for all the APIs that are by element that also allow the the selected element vector to be 128 or 64-bit independently of the other operands, we should have a separate overload.
Sure. Yeah, that makes sense.
Okay, so I guess we just need to add more overloads.
Yeah, I was trying to convince myself out of just using a flag for this, but since you're actually changing the parameter types, I don't see a way to do that without adding the overloads. Yeah.
Okay.
How many combinations are we talking here?
It's just one extra overload for all of the bi-selected scalar variants.
But only for the ones that take 64-bit vectors, correct?
Right.
No, all the 128-bit also need one that take a 64-bit overload as the third parameter. So
Got it. Okay.
So for each vector 64 will have one additional one, vector 128 will have one additional one. I don't know if it's how trivial it would be, but another option is we just always take that third operand as vector 128, and we look for a pattern around using vector 64 to vector 128, and then pick the right encoding based off that.
So for the ones that take vector 128 as add and left and 64 as right, we think it's impractical to just tell people to call dot get lower on that third parameter.
Well, it wouldn't be calling get lower. You'd have to, if you already have a vector 128, you probably want to call the vector 128 overload.
Yeah.
But if you have a vector 64, then you have to extend up.
Sure.
Which means that you're going to be taking up an additional register slot.
Okay. And you think it's common enough that people will have a combination of 64-bit and 128-bit vectors?
That I don't know.
But what do you mean by taking an additional register slot? On ARM64, 128 and 64, it's exactly one register. You're not taking another 64-bit register, right?
Right. But I guess my question was, how common is it to use 64-bit vectors in processing like this? Like, are we going to be adding overloads that literally none of our audience will ever call?
Mm-hmm.
Well, so one of the cases, for instance, where I frequently use such overloads is when I have to create a constant, and it's just replicated across all lanes. I tend to use a smaller register, and then get a zero index from that, so that I only have so I have a smaller load, or a smaller movi or something.
Mm-hmm.
And that's an optimization that can't be applied to 128-bit vectors in that parameter. Creating them from a scalar constant.
Not if it has to actually create the 128-bit vector.
Okay.
But I guess in principle you could optimize that at the call.
Sure.
But in general, the use case is that, for instance, you did some other calculation and you got a number out of it, and you just want to do a multiply with it, for instance.
Okay. That scenario makes sense.
So then how about this? Because I really cannot visualize what this looks like. Like one of you just paste in the actual APIs you want to add, and then you can just quickly approve it. But then, let's not wait for this. Let's just review the other one first, and then.
Yeah, I can do this.
Yeah, that would be
also really just
Yeah, the thing that was throwing me off is this was proposed as an overload to existing approved APIs, but we couldn't find the approved APIs anywhere.
Yeah, it's actually in the in the same proposal, except it hasn't been renamed inside of the proposal. So I think there it's called multiply add still, or fuse multiply add.
Yeah, but normally I post the entire API service of what we approved, so it should be in there somewhere. But it's possible that it's hidden by GitHub's friendly. Click here to load more comments kind of situation. But maybe like a full text search should have been able to find it. Okay, this was the first issue that we talked about, right? And so what's the second one? This is the second one. Oh, this is the second one. We started with the second one.
No, we just reviewed both.
Oh, they're the same comment.
They were just listed in the. No, there was. The other one we reviewed was the element index, which was just above this comment.
Oh, this one.
Yeah.
All right, then. All right, so then if you come back with the actual API, you can just quickly amend this. All right, now it's time again to walk a blob of APIs. So Tana, do you want to walk us through them?
Yeah. So I'm going to introduce a couple concepts here real quick. So on ARM, many of the instructions have a few different overloads. So there's the base instruction, which just does the normal operation. And then many of them also have versions that do rounding or saturation. And so that's where you see, for example, add high here and then rounded add high. They're essentially the same instruction, but there's a bit changed in there, in the underlying instruction name differs slightly. But they perform the same operation, only differing in, for example, whether you round the result versus truncate it. So a rounded result would be 2.5 goes to 3, whereas truncated would be 2.5 goes to 2.
It looks like you're adding integers here, though. Why would you need to round?
Because if you do 5 divided by 2, you either want 3 or 2 as the result, depending on the direction you're going.
Yeah, these add high APIs are basically the equivalent of divide by 2 to the 16 or divide by 2 to the 32. Ish.
Yeah,
I mean, I'm simplifying, but yeah.
Yeah, so in the add case here, you're basically doing, for example, 65K plus 65K, and then you're only taking the upper 16 bits of that 32-bit result. In which case you want to round based on the lower 16 bits there.
Gotcha. Makes sense.
Is that comment on rounded add high correct, by the way? Like it says upper half left lm plus right lm plus 1. Shouldn't it be like, is it actually that, or is it left lm plus right lm plus 2 to something?
Let me double check. It is sum equals element 1 plus element 2, sum plus round constant, and then take sum bits 2 times e size minus 1 through e size. So that comment should be correct.
Well, it seems like the round constant might be different based on the size of the data type that you're working with.
Yeah, round is 1 left shifted by e size minus 1, else 0.
Okay, yeah, so got it. Yeah, so the comment is, the comment does need to be updated.
It's not plus 1, it's plus
2 to some power, depending on t. Okay. Okay, that makes more sense. Cool. So I guess if we want to start, battle royaling on names, my first comment would be, we're not actually adding the high components of the inputs. We're adding the two inputs and then taking the high component. So the name reads a bit strange to me, but I can't really think of a better name, to be honest.
The closest concept we have is in system.math. We've got big mul, and we've also got like multiply high. And those are the closest existing concepts we have for some of these, where big mul is you're taking, for example, two 32-bit values and producing a 64-bit result. And then multiply high is the same, except you only return the upper half of the result.
Okay, so we have precedent for this name then.
Yeah.
Okay.
So Cameron, quick question. Is there a particular reason why you called the lower one add high and the other one add high upper instead of add high lower and upper?
For the add hn and add hn2?
Yeah, so it seems you call the two variants of the functions always upper, but you don't call the non-two ones lower. Just wondering if that's the correct convention.
Actually, that might be because in the other places we've used add high, or we've done op high and op low to indicate whether it's working on the upper or lower half. So that might be an oversight on my part due to
Maybe are you cooking now?
needing to use high as the name for the result.
The instruction uses the term narrow. Is there any reason why that should or shouldn't be in the function names?
We could call it add and narrow. I don't know how we would specify that it's narrowing to give the upper half of the result.
Yeah, normally when we use the word narrowing elsewhere, don't we tend to mean just chop off everything above what doesn't fit into the data type?
Right, and in this case, we're taking the upper half that would normally be chopped off.
Yeah, so like add low, for instance, would be the equivalent of what we think of as narrow.
So back to Tamar's comment, for most of the operations we've exposed so far that have high and low variants, we've named them, for example, add high and add low. But obviously that's going to conflict with the name that I used here for add high. Do we have a better name we can use for give me the upper half of the result?
Can't really think of anything because this is logically two operations rolled into a single instruction, isn't it? So we can't just tell people to write two different methods because it would have different behavioral characteristics.
Right.
Like you don't want to spell out the full name given in the manual, add returning high narrow.
We could, but that might it wouldn't fit in with the other names that we've picked so far.
Sure.
Maybe we could call it add high result.
Or add and return high.
Yeah, maybe that would work.
I was about to say that seems reasonable also.
I mean, one of the downsides of that is that we start getting pretty long method names.
Yeah. In which case, the ARM64 specific variant for add hn2 would be add high and return high. In this one, we might want to name add low and return high.
Sorry, add low and return high?
Yeah, so there's basically two parts to this instruction, similar to some of the other ones we've reviewed, where this one in particular deals with the lower half of the vectors. And then there's another one which will do the same operation but write it to the upper half of the result. Because you're narrowing the result from short to byte, you end up with a vector that can contain twice as many elements.
I see. Yeah, I have to say, a good chunk of these will always end up people have to read the manual boy, so
yeah. Should have just used the instruction name.
Yeah.
I keep coming back to add high as a good compromise, though, because again, we have precedent from the math class, and it's succinct.
Yeah, I guess the problem with it, though, is what Tamara raised, which is once you also look at the second half of the instruction, the names don't fit, because what we've done so far would be we would end up naming this add high, and this one add high low, based on our existing conventions.
Oh, that's
add high returning high and add high returning low sounds like the least bad of the clear answers.
Yeah. But then you're very low volume.
Yeah, that's the good headset in my alternate location.
Right, so then add low and return high it is. Unless somebody has a better idea.
Is add low the right thing to use here as a name? Because it is adding the two elements in their entirety. It's not taking the low parts of the elements and adding them. I guess what I'm confused by is how did we come to add low and return high?
Yeah, that was the thing.
So I think
I just explained, and I'm not entirely sure I fully got it.
So the add HN instruction writes the vector to the lower half of the destination register and clears the upper half, while add HN2 writes the vector to the upper half of the destination without affecting the other bits of the register. So they both do an add high operation. They both do the operation described there in the comment or in the summary. But it's a question on whether they write the result to the lower or upper half of the destination vector. So it's doing an add high and then it's write result to lower or upper half of destination.
Oh, right. But in the other instructions, I think you use an upper suffix to denote that you're writing to the upper half of the output, correct?
I thought we used high and low in the name of the instruction.
I think part of the confusion here is that the types in the instructor should be, the input should be factor 128. Since TA is always a 128-bit value.
Sorry, are you referring to the input parameters or the output?
The input.
Okay.
So it's going to do the operation on the lower part of the 128-bit factor. Which is why you have the upper component, because you can only do half the vector, and then you need the other part to fill in the remaining half.
I'm just going through the proposal looking for the API that operates on the upper half of the 128-bit inputs?
It's under the ARM64 class.
Okay. Still looking.
It's the first one on the under ARM64.
But that takes 3 inputs instead of 2, so it doesn't seem like a proper analog of this API.
It takes 3 inputs because
it's a combining. Yes, it combines. Okay.
Yeah.
Yeah.
Yeah, and Tamar would be right. It should, the instruction encoding takes a vector 128, and then the encoding specifies whether or not you're working on the lower or upper half.
Got it. So behaviorally, even though it's returning only 64 bits of useful data, is it actually effectively zero extending the entire register? So that
it's zero extends the result.
Okay. So the upper 64 bits of the result are all cleared, basically.
Yeah.
Does it make sense if we change this to take vector 128s as inputs to also have it return a vector 128 as output? And then say the behavior is such that only the low 64 bits are populated?
In order for it to, so the C++ intrinsic has it taking in vector 128 inputs and returning a vector 64 output.
Okay, and we'd prefer to keep the consistency there?
Yes, I think so.
Okay.
So and then on the other half, it has it returning a vector 128, taking a vector 64 lower, and then taking vector 128s as the left and right. This is for the ARM64 second half version.
Okay, yeah, so if we change the parameters here to take vector 128 as input, then yeah, I think putting lower in the method may make sense.
And I probably made that mistake on a few of these APIs where they say vector 64 and they should be vector 128.
Sure.
Specifically for the two halves APIs.
So it wasn't add lower and return high?
Yes.
Okay.
So I was just typing. So what was the conclusion? Add low and return high?
Yes.
Okay.
With returning.
Sorry, what was that, Jeremy?
Is it add low and return high, or add low returning high? And implies it's doing two things.
Sure, I can go either way.
And Tanner, just to double check, you said there's an easy way to go from a vector 64 to a vector 128, right?
Yeah, it's a zero cost conversion.
Okay. Now I was just going to add, because for some of these intrinsics, it is quite handy to have the Factor 64 overload, but if there's an easy way to do it, then you don't need it.
Yeah, at least for ARM64, it will be a zero cost conversion. For ARM32, since the Vector 128 to tract is 2 registers, if we ever support it, it might be a little bit different.
And that's not an unsafe operation to do that extension?
No, because on ARM64, it's the same register slot. Just like on, it's like XMM0 to YMM0 on x86.
Yeah, but I thought that the conversion from 64 to 128 was unsafe if you wanted it to be zero cost.
So in particular, in this case, because it's only operating on the bottom half anyway, it's just a matter of type checking, of getting past the type checker.
Yeah, unlike x86, where the upper bits can be preserved or zero depending on the operation and encoding, on ARM64 they're zeroed.
Okay, got it. So we can make that optimization within Midget then?
Yeah.
Okay, sounds good. What I was just trying to avoid was having people, write out the words unsafe or dangerous every time they wanted to call these APIs.
Well, they already have to because pointers, but...
I mean, if you're not dealing with memory, if you're just dealing with actual register data, but yeah. Sure, fair.
All right, so then let's review the second API.
So the second one is the same API, just with rounded. Is everyone fine with rounded as the prefix for an operation that rounds?
Yeah.
So this would now be rounded and low returning high then,
right? Yep.
I mean, just considering IntelliSense, do we want it as a suffix instead of a prefix?
I would expect it to be a suffix, personally.
So add low rounded returning high? A suffix to the add low part?
Yeah, verb suffix.
Yeah.
An infix suffix.
Yep.
So rounded. Add low rounded returning high then.
That sounds fine to me. Just noting that when we get to some of these later APIs, we might have to tweak the name some, because, for example, there's variants that are something like op, round, and saturate, lower, etc. There's some very interesting combinations, so just noting.
I should just stick to the CPU names.
If we want to say that the intrinsics are weird and we want it as a prefix, that's fine. I'm just, if we want it to group together in IntelliSense, then it can't be a prefix. So that's the only consideration.
Right.
Well, if you put it as an infix, then all of the add low roundeds would stay together, separate from the add low.
The other interesting bit is making sure we don't. The ordering of the intrinsics of these keywords in some cases can be impactful in how a user might interpret the result X. Just another thing for us to keep in mind. I don't think there's any for rounded in particular that fit that, but some of the others might.
So infix it is.
Yeah, the one downside of doing an infix is that grouping is much harder. Right? If you have an actual pure prefix or an actual pure suffix, it's at least clear that the rest of the instruction is the same.
Yeah.
If you put it in the middle, it's kind of a little bit odd.
Well, it just means that all of the rounding operations are grouped and all of the non-rounding operations are grouped. I'm sorry, all of the rounding add low are grouped, distinct from the non-rounding add low, but they are still separate from the rounding add high and non-rounding add high.
Yeah, in particular, in this case, we're doing an add rounding and then taking the upper half.
It gets weird. This all gets very weird. Okay.
Yeah, I don't have anything better at this one. Let's just keep going and see where it leads. So halving add.
Yes. In particular, I called this one halving add because I didn't think add half made sense. Specifically since this is doing an add and then it's having the result.
And this is subject to overflow. As in when you add the left and the right element, is the intermediate result truncated to the element width, or does it keep the carry bit around for the final division operation?
Tamar, do you know? That's not something that I had the opportunity to check yet.
No, I haven't completed this anymore.
So in particular, this would be impactful for int.max value plus int.max value divided by 2.
Yes.
Where if it's fused, it will return int.max value. Otherwise, it will return int.max value divided by 2.
Yes.
Minus 1, something like that.
Yeah, well, I was also thinking I think adding int.min value and int.min value divided by 2 could end up in 0 as well.
Yeah.
But how would that change the naming of the instruction?
It would be fused or not, right, Tanner?
Yeah, I think we would. If it's a fused operation, we would prefix it with fused having add, I think.
I see.
So for prefix versus suffix again, do we want it to group under H or under A? So add halving or add halving or halving add, and then the next one being add halving rounded, or etc.
Yeah, I don't know if add halving in particular. I guess if it's add halving result or something, maybe that will be clear enough to users that it's an add and then a half, rather than half the inputs and then add them.
Yeah, I think you probably want to. I mean, the primary instruction is clearly the add, right?
Clearly the add, right?
Yeah.
No, I can't seem to tell for this particular instruction if it's fused or not, but I don't believe it is, but I can ask.
Let me see if while we're going through the other ones, I'll write up a program and run it on my Surface to see what it outputs.
So assuming it's non-fused, we would call it add halving, whatever it's pronounced, and if it is fused, you will prefix it with fused. Is that fair?
Yeah.
And then I guess the next one would be I guess add halving rounded then.
I think it would be add rounded halving. I think
yes.
Specifically because you're doing an add and then a round and then halving.
Fair enough.
Yeah, I agree with Tanner on that.
It was three words. I only had one chance to get it right. All right. So then the next one would be add saturate. I think that seems reasonable.
I think your comment for add saturate might be wrong, Tanner.
Yeah, I was just looking at that. Yeah, it's definitely meant to be a plus there, and there's supposed to be a comment that says it saturates that result.
Yeah.
What does saturation mean?
You don't overflow from positive to negative or vice versa. It basically gets capped at one of the maximums or minimums.
Yeah, so int max value plus 1 returns int.max value rather than 0.
I see.
So saturated, saturating, saturate seems wrong.
On x86 we used just the word saturate.
Yeah, I'd keep this as is because it matches x86. And when you have the T here, that just means it supports every integral data type, right?
Yeah.
And float?
No, actually, I've got a comment that says it supports byte, sbyte, short, int, and u.
Okay. And then the 64-bit one will support u. Okay.
Yeah, long and u long.
Sure.
All right. So saturate we were fine. So we'll pass that then. So I guess this is now.
So exact same thing that we said for the add ones, just replaced add with subtract.
I would think so.
Yes. For it's all the same operations, just subtract now.
So it would be subtract low, returning high. Okay. And then the other one would be subtract low rounded returning high. There's no way out. And then halving subtract would be subtract halving. And then the other one is just subtract saturate, right?
Yes.
All right. Okay, is this different from what we had at the beginning?
So this one is the other half of the original variant. So you can see it takes an additional parameter as the first one, which specifies the lower bits of the result.
And I think we had said earlier, please correct me if I'm mistaken, that here left and right should be vector 128, not vector 64. And you only operate on the upper components of those vectors, correct?
Right.
Okay.
Sorry, so all the types should be for left and right should be vector 128 then?
Yes.
Yep.
Except but lower still. Yeah, that's what I thought. Okay. And so what is the name then going to be?
I think we said add low returning high versus the other one, this one's add upper returning high in contrast to the add lower returning high.
Add upper returning high. So yeah, that makes sense. And so on the next one, the rounded one, same thing, with the left and right should be 128.
Yeah.
And then the name should be add upper rounded. Returning high. All right. Okay, add saturate scalar. Seems reasonable. Given the other name. Except when you say scalar, I would expect the scalar value, not a vector value.
This is because there's two parts. One is if we took a scalar, the JIT would have to have significant work in order to understand that integer values can be held in SIMD registers. And the other part is we're actually taking in the actual thing taken in is a vector 64. It's only operating on the lowest.
So what does that mean? One of them is literally an int.
This mirrors what we did. This mirrors what we did on x86. So it will be a vector 64 of int, and it will only operate on the 0th element of that.
I see. All right, the next one are easy again. First, let me fix the type for left and right. And then it's going to be subtract upper returning high. And then the next one 128 for right, 128 for left, and then it's going to be subtract upper rounded returning high. Is that right? It's a bit weird that we use upper as the opposite of low.
Well, it's upper and lower.
Yeah, because before we called it subtract low, not subtract lower. Should we then call
I think we had said lower, yeah.
Okay, then let me go through all of them again.
We'll fix it in post-production.
Okay, add lower returning high. Add lower rounded returning high. Yeah, rounded high, okay. It's quite sad that nobody can see my amazing multi-carrot editing. I feel like a ninja. Alright, done. Alright, subtract scalar. Seems reasonable. Alright, add pairwise and widening. A new concept.
Yeah, so this is doing a pairwise add, but the result is twice as wide as the input. So S byte becomes short, byte becomes U short, int becomes long, etc.
That makes sense. Or add pairwise widening, because we didn't use and in the other names, but whatever.
Yeah, that would be fine too. It's the same number of characters.
It is.
Sorry, so add pairwise widening. And I guess you do the same thing for the second group, right?
Shouldn't the name of the second group contain accumulate or something?
We had used add elsewhere as the suffix. Add widening sounded weird.
Yeah, I think, but like it is now, the instruction seems kind of ambiguous to me. If I were to only look at the name and then the signature.
Yeah. Do we want to call it add pairwise add widening?
Sorry, add pairwise add. I don't know what that means.
Well, so in other APIs, we had used add as a suffix to indicate that the result was added to an addend. Because basically this is doing add pairwise, and then it's taking that result and adding it to an existing value.
I see. So there's basically two additions going on then.
Yeah. And actually it's add pairwise widening and then the add operations performed.
Yeah.
So in English, that's effectively add, pairwise, widening, and add?
Yep.
Okay, ship it.
Sorry, say this one more time slowly.
Add, pairwise, widening, and add.
Okay, that's not too bad. Have you won the element to be the first one, not the second one?
Yeah, because that's the way the instructions encoded, and how we've ordered the other ones because of that.
Fair enough. Absolute difference and widened low. Should this be widened lower?
Yes, I think so.
So they all go to unsigned? Is that intentional?
Yes, because it's an absolute difference. So it's returning an absolute value.
Okay. And then absolute difference and wide and high should probably be upper then? Wide and upper?
Yeah, that should be upper, not high.
And this is another one where the factor 64 should be 128, I think.
Yeah, that would be the other case.
Sorry, the absolute difference and wide and lower should take vector 128 only?
Yeah, because they're operating on the lower half of a vector 128, not on the lower half of a vector 64.
I see.
And presumably that comment about the operation is wrong.
Yes, that there should be an absolute value symbol in there. And it should be subtract. Actually, Tamar, is this one operating on vector 128 because of the widen operation? Oh no, I guess it is. I just missed that part of the spec.
All right, so oh Jesus, the touch display is horrible. All right, let me scroll for keyboard. Where was I? I think somewhere here, right? Absolute difference. Yeah. So absolute difference add and widen low should probably be absolute difference add and widen lower. And presumably,
or I think we said absolute difference widening and add. Or no, absolute difference widening lower and add.
All right, that's the other thing. I need to fix all the add, widening. Yes, absolute difference widening lower, absolute difference widening upper, absolute difference widening lower and add. And then presumably they also take vector 128 for left and right.
Yes.
Is there a non-widening version of these APIs, or are there only widening versions?
Yes, I believe there's non-widening, and I believe we already reviewed them.
Okay, great.
All right, then the next one is absolute difference widening upper and add.
Yeah, we called it absolute difference add for the already approved and reviewed API.
That's actually not bad.
And also on the ones we already reviewed and approved, we have them taking vector 64 rather than vector 128. So maybe that's something we need to fix in retrospect.
Hold on, say this last part again. What do we need to fix in retrospect?
So we were saying for these ones, they shouldn't be taking vector 64 left and right.
Yes.
They should be taking vector 128. On the existing reviewed and approved API, in 24794, they're taking vector 64.
Sorry, 24. What was the other one?
794.
794. Should take vector 128 rather than vector 64. All right.
So a quick question. I see the subal and subal 2 there multiple times. Was one of them supposed to be something else?
Hold on, let me get back to the right window.
I think you just split the 64 and the 128-bit versions, right?
Oh yeah, that's what it looks like I did.
But the 128-bit versions below are correctly accumulating, and the one below on top of it are not accumulating. So that instruction doesn't match up to this.
Oh, it should be SAB DL, not SAB AL.
Ah, okay.
Yep. Actually, I think I see why we did it as vector 64 rather than vector 128 here.
Yeah, vector 64 is correct for SABAL 2.
Right, but for SABAL, you were saying.
Yeah, no. So for SABAL, you're right. It should be vector 128 for the addend and 64 for the inputs.
Okay.
So we're saying
so that is right.
Absolute difference add shouldn't have taken. So it actually is correct.
Yes, except. Does that function there take 2 or 1 argument? I can't see past the addend.
It takes 2 arguments, left and right.
Okay, that's correct.
Okay, so they're correct in taking vector 64 and having separate overloads that take vector 128 here.
Yeah.
When you say here, you mean in the other issue, though, right? What are you talking about? So which one are we talking about? Right now?
We're talking about SABAL and SABAL 2, but it seems to be so the first SABAL on top is a typo. It needs to be a different instruction, and that's where the confusion came in.
I see. So the one that we have here right now, so I fixed pretty much all occurrences for the previous one from 64 to 128. We're saying that was not correct.
Correct.
So that means everything where we say widening lower. So okay, let's go over the list. So the very last time we reviewed was absolute difference, widening upper and add. This one should remain on 128, or should this be changed?
Which one?
Yeah, that's the problem. So basically, the one we're looking at the screen right now at the very bottom. Let me actually scroll down. Yeah, so ignoring the add and wide and low, we just look at these groups here. So this one here. This takes 128 here. That presumably is correct.
Yep.
Okay, then the previous one, which takes 64 here, is also correct.
Yep.
Okay, so then let me fix this here. Alright. And that's probably true for everything before as well, right? So
the only difference is the comment. So the comment is wrong. The instruction isn't SABAL, it's SABD.
I see. So this one takes 64 then. All right. So everything we did before, where we had upper and subtract upper and all of those were correct fixes to 128 though.
Yes.
Okay, so then we don't have to go over it. That's good. All right. So I think I got it then. So we're then done with the absolute difference, and we can just move on to the add and widen low.
Yes, I think so. And I think we said these should be add widening lower and add widening upper.
Yeah, so yeah, I've already fixed the lower and upper here. So add widening lower, add widening upper. And then add widening lower has logically two overloads, one with 64, one with 128. Right, and then I'm confused now. Hold on. You seem to have a duplicate group. Yeah, so add and widen high here occurs twice. Both of 128. Right, so this group here seems to be the same as this group here. You probably want these guys to be 64 with them, I guess, right? Right, because these two groups here are logically related, right? And so
they're different in structure.
Sure, but these based on the 64-bit version, so it's the 128 version. I would expect these two guys also to have the same pattern. But they basically right now identical. Right, this one here is the same as this one here.
Right, and they're different instructions, but I don't remember how they differ.
Yeah, but you need to change the name at least of one of them. Otherwise you have the same signature.
I'm just trying to see what the difference is. So element 1 plus element 2 take double the bits versus well, the operation description is identical, so
yeah, I've been trying to figure out what the difference is between the two, so
maybe it's a difference between whether it's a big add or a add and then widen. Oh no, I think, do I see? No, oh, I see, and I see also why it's fine. So there's actually no conflicting overloads here. They are functionally similar. The difference is the first set does s byte plus s byte equals short. The second set does short plus s byte equals short.
Yeah. Let's start it. Okay. And it's intentional that they both take 128.
Yes, because in the latter case, you're taking a short, and so it's going to be twice as wide. It's the same size as the result.
All right. So then all of these should be named subtract widening lower.
Yes.
Okay. And then I guess these are all multiply widening lower / multiply widening upper.
Yep.
And then the other ones, basically this group here, should all be multiply widening lower and add. And then multiply widening upper and add. And then multiply widening lower and subtract them. And multiply widening upper and subtract. All right.
Yeah, that sounds right.
Wow. All right. Then I guess we can close this one here. So hopefully this one text is not quite as long. Because we only have 35 minutes left. All right, Tanner, take it away.
It might be good if Tamar does this one. This one's his proposal.
Right, so essentially a table factor lookup is a pretty simple instruction. It takes a list of registers that must be consecutive and a list of indices of the element indices inside these factors, and then returns to you a new factor. So because of this constraint that the registers must be consecutive, I created a new type, or basically based it on a tuple. But you probably don't want tuples since you don't want the constraint to apply on all tuples. And also there's the odd case where you have the factor lookup into one register. So that one probably doesn't want a tuple because I don't think C# supports unit tuples quite well.
So you're using the existing value tuple type, right? It's just that you use the one that only has one element, right?
Yeah.
So something that Igor and I had discussed on another one of the issues was, rather than using value tuple here, we could do what C++ does and define a custom type. For example, we would have vector 128 by itself for the single element, and then for the 2 element tuple, we would call it vector 128 x2, which roughly mirrors how matrix 4x4 works, for example.
So maybe I'm still not clear. You say list, but it's still just one element. Though.
For the one element case, but you can have up to 4 registers. So if you look at the different overloads, you can have.
Oh my goodness! I see now. I found it. Sorry. Yeah.
So the reason I originally went for tuple is because syntactically it's the easiest way to pass for registers.
Yeah. So is there any reason why the vector table extension that takes just one element needs to be value tuple of one element?
No, that can be just a single register.
Because then you actually have then it would be actually in favor of using value tuple because then you have uniform syntax to call them all. Right, C# doesn't support single element tuples because it would be syntactically ambiguous with a normally parenthesized expression. So they but then it kind of makes sense if you can just put parentheses around your 2 or 3 or 4 vector type other than inventing a new type because that would be much uglier to use. I mean, I'm not sure how nice the code reads when you call these APIs in context, but it seems like the most obvious way to pass multiple values as a single value.
So my only question there is, I don't know if the register allocator can add the constraints only for these functions and not everywhere you use a tuple, or if we need a new type deriving from a tuple.
There was some discussion starting at the comment that Igor just linked to, but Carol would be the best person to comment on the register allocator.
If I can find the unmute. So this is something that's going to take some time to support. I think we should go ahead and define the API, but I think there's some question whether it's something we can do for .NET 5. The biggest issue, I mean, partly it's going to be a bit of work, but the biggest issue will making it pay for play. It's probably going to be an impact on throughput, just to have to check if I have this case. So I think that making it sort of pay for play will be actually the bigger part of the work, if that helps.
But in your world, does it change whether it's a custom type or whether it's the existing tuple type?
Oh, I'm sorry, I wasn't answering the right question. So
Carol, you just cut out.
Yeah, I just hit the mute button again. Sorry. So whether it's what the actual type is. My suspicion is that we will probably want to have a special type in the JIT, and whether we convert something to that type in the importer or whether it comes in as this special type is probably not a huge impact. Make sense?
Oh, it does make sense. But what I don't quite get is how would a special type make your world easier though? Like, isn't this whatever work you have to do would be the same amount? Or would you envision this new custom type would have a different layout that would make that easier?
So, I guess maybe I left a wrong impression. I don't think.
Muted again, I think.
No, I'm just trying to figure out how to say what I want to say. I don't think it's a big difference either way.
Okay.
I think that within the JIT, we'll have to, that the only way to handle this will be to make this a special support, to make these special supported types. But what I say, whether those get created in the JIT or whether they are, come in as differentiated types, it's just a matter of how much work has to be done in the importer.
I would imagine, at least from the perspective of usability, it might be easier to define a custom type. One, it lets us extend custom functionality on that in the future. For example, debugger display, things like that. But it also we can make sure that it's immutable and some of the other niceties. Value tuple has public fields, which means users are free to take the address of them and do all kinds of weird things with it, which might make it harder to do various optimizations. And we could prevent that with a custom type.
That's fair. I mean, like if you really wanted to get fancy, if you want people to just be able to call the vector table extension one with the tuple, you can always have an implicit conversion from the tuple to your custom type. If you really wanted to, right? Like, I mean, that's. I was just commenting on that. If it's the same to you, I would rather use value tuple because it makes people get language syntax for free. If you see there's other tangible value of a custom type, then I also have no problem with a custom type.
So I may be like completely misremembering, but I think we want to be consistent between this and things that return multiple registers. And I thought there was an issue with returning a value tuple. Am I misunderstanding?
I don't think we've had an issue with returning value tuple, but so far all the APIs that have returned multiple results have used result and out. We've not used value tuple.
So that is a bit problematic. Just saying, to the JIT.
Well,
I mean, once you get the address of something, it's just a little more work to try to figure out that you didn't really mean it.
Yeah, so to me, the reason why we do usually has nothing to do with tuple per se. It's just the problem with versioning APIs. Like if you return a tuple, you're basically stuck with you're returning 2, 3, or 4, whatever your decision was, because you can't overload based on return type, right? But you can overload based on number of out parameters, right? So if you want to add one more thing in the future, you just add an overload that takes another, or that outs another value, right? So in this case, though, because the instructions are clearly tied to either 1, 2, 3, or 4 elements. I don't see a problem with returning a tuple in those cases because we never have to version this, right? It's fixed by contract. Does that make sense? Did I just confuse more?
Makes sense to me.
Okay. Yeah, the problem with online meetings is we can't tell people reactions. You just hear silence. Sometimes a bit unnerving. All right.
It may be a bit late, but I won't digress. Sorry, never mind.
Is it the case that we would define these before we have a JIT implementation to validate our assumptions about how difficult these would be to implement, say for .NET 5, or would we not define these until we knew we had an implementation that works?
I don't think we could publicly expose them until we had an implementation that works.
Yeah, that's from defining it so that at least we have a plan, right?
Right, I think it's fine to define them. We just can't expose them until we have something working.
It seems like the multi-register load and store ones might be more important if we were going to assign a priority to defining and implementing an API around these. Is that fair?
Well, we could also expose them and have a less efficient implementation, temporarily speaking, and then have a work item telling people that these ones aren't true intrinsics yet, they will be in a future release.
Well, that actually locks us into the API shape.
Yeah, that one does.
Right.
But in terms of your first questions, yes, I would say the loads and stores are more important than the TBLs.
And have we actually defined and reviewed an API for the like the load 2, load 3, load 4, etc.?
There's a proposal for that. It's 33490, which is the thing that Igor linked to above with some of the loose discussion around it. But that's not gone through review yet.
Okay, and you would have the same question about how to represent the multiple registers,
yes, but
consecutive registers.
But specifically on returns rather than input parameter.
Okay.
So what I'm hearing is these APIs are not quite there yet. Should we then just skip them for review entirely, or
we need the single element version for .NET 5. It's the 2, 3, and 4 element versions where we need to determine an API shape in which we might not be able to ship in 5.
Okay, so that means every overload here that is taking a tuple with 2, 3, or 4 elements, right?
Yeah, and we're just going to, I think in either case, whether we do tuple or custom type, we'll just be taking in a vector 128 for the single element version.
Okay, we don't think we're ready for the overloads.
So what do we have to do to figure out how to represent the multi-register form? There's the value tuple case or the custom type case. Is there another? How do we make that decision?
Yeah, to me there's two dimensions. One of them is pure usability of the APIs, which I already wrote some notes where we can see how this looks like. What's appealing with tuples is people get language syntax, but probably depending on what you think people would do commonly, you might get almost all the benefits without using tuples directly. Like you could have implicit conversion from a tuple to your type, which would be hopefully transparent to the JIT, because basically people write tuple syntax, but when C# lowers that, it will just basically construct the tuple and then directly construct the whatever custom type you have and pass the 3 or 4 arguments directly to the constructor, which should just work. And then same thing on the output side, if we return this custom type, then we can add the deconstruct method, whatever, to allow people to immediately deconstruct it into like 2 or 3 locals with even outgoing through a value tuple, right? I mean, that's really the only benefit of using a tuple, right? If it weren't for language syntax, I would probably just say use a custom type, similar to how we did it for Vector 64. And that might be the easiest way of doing it. So I would think that in order to determine that probably JIT works, the way you guys have to figure out what limitations you have in loading those, and then see how that plays with language syntax on our end when we use a custom type. But also I wouldn't over-index on that, because I mean these are not the API visibility is the higher order bit. Right? Like even if people even if we can't make video tuple syntax language work, I don't think that's the end of the world either, because these are not the APIs where oh my god, if you can't use tuple syntax, then bad things will happen, right? It just seems like a nice thing. If we can get it, we should do it. If we can't, then so be it.
And we should determine what downsides in the JIT there will be with value tuple having public fields.
Yes.
Wait, did I miss what's the issue there?
The fields are public, so users are free to do to take the address of individual fields, read and write individual fields, etc.
I see.
So it's just it's a potential concern where there's more places where a user could be doing something they think is clever, but in actuality ends up hurting code gen.
Yeah, I'm not sure. Yeah, I mean, if you need to be able to reference those individual elements anyway, which this is probably a side conversation.
Well, it's basically the case of like if you with the vector types, we've got specific get element methods that are able to explicitly optimize, for example, getting the x value of a vector 128 float to a specific instruction. If we have a custom type, we can likewise have the property getters for the, element 0, 1, 2, and 3 that are specifically optimized by the JIT, knowing that it's otherwise immutable. Whereas with value tuple, that will be much harder to recognize and specialize.
Yeah, I'm not sure. I'm not sure where the balance winds up on that, because having the extra stuff to support versus, okay, well, it just falls out of the JIT support for structs with fields, right? I'm not sure which is going to be a better scenario. So,
right.
I don't know.
So, Carol, would you say that we need to do some experimentation here on which way would work best?
Well, I would love to. I don't know where that winds up relative to other stuff we're working on, because I don't know that, without actually getting to the point where we can register allocate these things, I don't know how much progress we can make on assessing that.
Okay.
Yeah, I don't mean to be a downer.
No, not at all. I mean, realism is an important dimension in design.
Harold, that will not have been the worst news anyone has received over the past few weeks, so it's okay.
Levi, I'm not sure that was an uplifting comment. So while you guys were debating, I just deleted a bunch of APIs. So basically, we are now down to everything that just takes a value tuple with a single element. Is it fair to say if I just remove the value tuple around that single element, so we just make it a vector 128 in all cases, then we are fine with that shape?
Yeah, I think that's correct.
Yeah.
Man, I really hope I don't fuck this up. There are so many. Yeah, this looks right. They have to go. This one goes as well.
So I know that vector table extension is the name of the thing in the docs, but I think it's kind of a terrible name, and maybe vector table lookup extension is better since it's lookup with extended semantics. If we're still talking about the methods that are on the screen.
Yeah, how about I project my screen for a second, because, or like I throw over the other thing, because there's so much editing going on now that I think, unless you see what I see. That is probably not going to help the case.
Yeah, I think vector table lookup extension or extended would be fine.
So this is basic. So what I did is I removed all the ones that take more than one value tuple, and then I just grouped them and aligned them so we can see what remains. Does this look right to people?
Modulo Jeremy's feedback on the names, that looks right. Did we decide that we're using IDX?
No, my goal is not to say this is the API we want. I'm saying these are the APIs that are remaining, and then we can talk about what we want them to look like.
Got it.
The ARM32 ones we can approve, but they won't be implemented for .NET 5. So we could probably comment them out.
That works for me.
And the value tuple from the list argument needs to be dropped.
Sorry, Tama, you just said what should be dropped? The value tuple should be dropped, probably, right?
Yeah.
How we do this? Second on that. All right, so this brings us closer to this. All right. Right, so IDX probably should be renamed to index, would be my guess, right?
I believe it's byte index.
That also works for me.
Wouldn't indices be better since it's a list of indices?
Okay, so byte indexes.
Yeah.
Wouldn't it be indices?
I think so, yeah.
Let me get out the book.
Yeah, I don't know if there's a special rule here we have or not.
Oh god.
In English, it would definitely be indices.
I'm pretty sure that's what we use, but also we don't have that many APIs. I would hope.
All right. According to the table of standardized names in .NET, we use indexes and never use indices.
Seriously. Jesus Christ. All right. So be it. Indexes. Okay, fine. All right.
I didn't write that. All right. Don't blame me.
I'm going through all of the files in libraries just to make sure that we're actually following those guidelines.
So what about the method names? You're fine with vector table extension, because that also does not sound like a verb anywhere. Like, what does this API actually do?
I think Jeremy suggested vector table lookup extension. That's actually the name in the manual, I believe, right?
Yeah, so the difference is just what happens when the index doesn't exist in the lookup. So the normal table lookup will return 0. The extended lookup will leave it unchanged.
I see. So then logically probably thinking them this way. Not that it makes a huge difference. Probably helps too. Quiet and home. Right, are we happy with that then?
I'm not sure I like the name list, but I'm not sure I've got a better option either. And likewise with result.
Are these basically just a gather operation?
I think it's more like an advanced form of permutation rather than gather.
Yeah, having result as a parameter name strikes me as a bit odd, especially one that's copy by value.
Are those default values?
Yeah, they're sort of like the template.
I mean, part of the naming of the list parameter depends on how we think we're going to expand the rest, right? Because we could make the method that takes 4 registers just take 4 parameters and deal with and make the allocator have to deal with that. At which point we would call them vector 1, vector 2, vector 3, vector 4.
That would eventually be inconsistent with the multiple element. Well, multiple element store could be okay, but the multiple element return would be inconsistent.
Yeah. Yeah, I mean, list is what it's called in the documentation, but they point out list can be a variable or semi-variable length thing. But yeah, I don't have a better name if we don't know how we'd do it. But we could, if we wanted to, just playing devil's advocate, we could expose the flat call versions of the 1, 2, 3, and 4s, right? And then we could add a packed one later if we add the packed register type.
Maybe list could be called table instead, since it's essentially the table you're looking things up in.
Yeah, that table might be a good name there.
Now it's not called list.
So you're saying now it is called list? Now it is called list? Is that what you said?
Now, if we rename it to table, then it's no longer called list and is no longer
I see.
Using a name that means something in .NET already.
Yeah, I mean table seems reasonable, right? Even though a table is also kind of weird here because to me a table something two-dimensional. But I guess it kind of is. But I guess you have the roles and then you have the the actual elements. I guess. So what about result? Happy with that?
The reason I don't like results as the name is because that's normally used to imply it's the result of the operation, rather than where this is the result of a vector table lookup operation.
Yeah, isn't that basically the extension that you pass in?
I guess it's if more than one source register is used to describe the table, the first source register describes the lowest byte. Oh no, that's the wrong comment. I was trying to figure out if this was equivalent to lower that we've used elsewhere.
Sort of, since it's being used as a destructive operator. I was going to suggest for instead of result, maybe default values.
So I guess it's a little bit unclear. How is the result used exactly in the computation of the actual result?
So if your index is out of range, then the value in the original result vector is used, or it's left unchanged.
Okay, so maybe we could just call it default or something. Default result.
I prefer default values over default result. Like, generally having result in a parameter name is a bit strange to me.
Default values works.
Sounds good to me.
So I was just typing again. What was the conclusion? No conclusion?
I think that the result becomes default values.
Default values, I see. Okay. Yeah, that works. So unless somebody has any major objections, I call it because we are pretty much done now, and we seem to have consensus on what we want the API to be.
Yep, that's fine. I did want to call out, I was able to check how add having performs, and it is a fused operation. So byte.maxValue plus 1 returns 128, not 0.
Okay.
So we're going to call it, I guess, fused add having, to make that clear.
All right. So that means in the previous one, we should. So which one should be fused ones? Everything that has halving in the name.
Yeah.
Let me just. Be a good boy and let the whole thing. Halving. And generally speaking, we want that to be the prefix, right? And it's fused.
So far we've done fused everywhere.
So it will be fused add halving, fused subtract halving, fused add rounded halving.
Yeah.
So there's no fused subtract rounded halving. Did we miss that, or did we just not have this one? It doesn't exist.
No, there is no rounded sub.
Yeah. Alright, so updated the comment from the other one. And the API ref as well. So, okay, cool. Then I think we're done for today.
Yeah, and so then remaining, there's a proposal for the shifting intrinsics. There's a proposal for the load and replicate APIs, and then there's a handful more that I need to finish getting up into a proposal, and the scalar variants that were missed.
Did you already file them? Apparently, yes.
There's 2 issues open so far, and then I've got, I think, 2 more issues that still need to be opened.
Yeah, so there's 4 issues that I see. There's load one single element structure and replicate to all lanes of one register.
And the other 2 are Intel.
Yeah, there's one ARM, additional shift intrinsics, and then provide x86 CPU. That's the other. And then there's the intro extensions. Yeah. So are all of them happening for 5.0?
The first 2 for ARM, I believe, are. The ones for x86, it would be nice to have, but I don't think there's any critical asks for them.
So my challenge is. So I think we have to. There's a few more APIs. Xamarin Essentials. We need to take a look at, which is probably going to be a full 2-hour meeting. Hopefully, we get away with just one of them. And then at some point we also have to review our backlog again, because I think at this point we just do a quick scan. It's probably not going to be pretty. Yeah, it's 47 open issues. Yeah.
And ASN reader.
Oh yeah, we need to finish this one. We probably should set up another one for that, because we're almost done with that one. So, let's do the ASN reader writer first, so that we don't lose momentum there. Then Xamarin Essentials, and then in the middle we should do one backlog review. So I think for ASN reader writer we set a full 2-hour slot, right?
Probably, and that's assuming that we work out the namespace offline, which we haven't started trying to do.
Yeah.
But we can always do that as the last mop-up item. Like the classes won't change depending on the namespace.
Yeah, I mean that's a fine files exercise. We should probably ideally we do it before the API review. Before the API approve it. I guess we can start the review anyway. All right then. That's pretty much all of it. And then see you guys at some point. All right. Bye.
All right. Bye.
Bye.